Lecture CO6, stick versus unitized facade systems. In this lecture, we're going to talk about stick systems versus unitized facade systems, the pros and cons of each system, functionality of the system, and where to use it the most. Facades are in general made to envelop an inner environment versus an outer environment. And as we learned already, it's supposed to not take any structural loads from the building, only the dead weight, and payloads are to be taken and then transported via brackets into the main system. With this lecture, we selected a stick system and a unitized system, random systems. The stick system here from Reiko, it's a timber stick system, versus a unitized system from Schuko, which we use in this lecture. You see, this is the stick keeping position, keeping the glass sheets in position, getting this fixed with a pressure bar, and then a final cover cap fixing it as a system. The sealant inside versus outside needs to happen at this situation where the glass and the stick are actually connected, versus the unitized system where we do not install sticks and horizontal rails, but entire frames which are already enclosed with the glass. So the sealant of the glass has to happen directly to the frame, and then the frames itself have to be connected to each other with sealant, so that each frame, being already tight, is connected to the next one to get a sealant in between the frames. We see 3 layers of these sealant, which is what we do with prefab systems. When I continue, this is a typical stick system which we use very regular in this lecture. The picture you know already as well. We see it's a main structure. This is main structure. Concrete skeleton structure. We see the concrete floor, we see the brackets, and where the stick system actually is fixed to it. This is the sample from Reiko. They have a very nice system to get the horizontal stick, the vertical stick on the horizontal rail connected. It's an aluminum sliding system, so both are pre-assembled with these aluminum sliders and then brought in position and then finally fixed with these screws so that they do not disconnect during functionality. Then this whole thing is closed with an aluminium bar. The aluminium bar has the function to take the screws from the outer pressure bar in position. It also has the function to take the dead loads of the glass, which we see later in the system. And they keep position for the rubbers, for the sealant profiles, which are brought in position. So below this rubber profile, we see the same aluminium profile in a vertical position. This rubber profile is brought in position, and as we can imagine, if this connection has to be made airtight at the inside, we need to be precise and sharp to get this cutting situation on site done nicely. This system supplier uses a certain device which creates exactly this sharp cut, which then exactly allows to get this profile positioned well, which then ends up in this general layout, the inner layer, and then later glass is positioned on top of it to needs to be airtight in this situation. This part is this takes the glass, so it's the bracket which takes the dead loads of the glass, which is also fixed to this aluminium bar as system. Next level of this, we see the inner sealant system bottom part. We come to that later. We see the outer pressure bar, which is putting to under pressure the glass in position, and then which is happened here in this situation where we see the vertical and the horizontals screwed through the system into the screw channel, and then the cover cap which is brought on top of it as a total system. Here we see the bottom part. The idea of this stick system is always that we need to make sure that if there's any humidity getting into the system, this humidity needs to find its way out of the system, and that's done with this drainage system. We have a separate lecture about that. Drainage system needs to drain at the bottom part out of the facade to not allow to have the water staying in the system, stick system. We do have various materials to do so. This is the timber one, which we already saw. We see the aluminium inner bar with the screw channel. We see the rubber profile. We see the whole thing is sealant entirely. airtightness is done here and airtightness is done here. And then this whole package is airtight as well. And this is the pressure bar here done in one piece, no cover cap to be added, and then the sealant, rain-tight sealant at this part. The screw penetrating into the screw channel as expected. Left side, we see an aluminium profile. We actually see it's exactly the same setup for the glass system, just the inner part is instead of timber done in aluminium, with the, say, pros and cons of using aluminium versus, pretty much right, a steel layout. This is a steel system with, again, this screw channel, and we see it's an outer aluminium pressure bar and cover cap system, which is done here, screw channel through the whole sealant, and then the sealant same setup as with the aluminium system as it is done. Now the unitized system, showed this with this sample of a unitized system. Unitized system means it's not a stick and a rail connected on site, then the glass plate brought in position, but an entire frame being pre-assembled in the factory and then transported to site, and that's what we see here. This is the pre-assembly in a factory. Then the whole thing is transported in these brackets, in these racks, to the construction site, and then installed bit by bit at the construction site. A system like this, a deeper sketch of this, this is a Schüco system, which was used in a building in Darmstadt. We see the horizontal and the vertical section. Horizontal section, you see, this is one of the aluminium profiles, the one part of the frame. This is the other part of the other frame, and they keep the glass in position. The sealant of the glass inside and outside happens here, and then these two profiles being connected, they have to be sealed at the inside, again airtight, at the outside again rain proof, and having an additional layer of rain-proofment as a second outer layer. So we have two outer layers and we have one inner layer. And we see the same in the horizontal section, the first outer layer, the second outer layer, and then the inner layer to guarantee that the whole thing is airtight as a total system. This is the construction site. You see you have limited number of people necessary to get it in position. That's the general idea of such a system, that you can easily install very fast prefab systems. They're either hung or standing systems. This is a standing system as it is made. These are the profiles, and we see the inner rubber to be positioned in here. We see the outer, the inner outer rain-tight rubber, and here we see the final outer rubber being brought in position. And you also can imagine that the joint, so we have one of that here, one of that here, and then this middle joint where all the four lines are coming together, that's always the most interesting one, to make sure that the rubber to really find their position nicely. Installation process, staple top on top, each other. This is the bottom part, and this is bottom part of outer sealant. We see the inner outer line, which is supposed to be rain tight, and then we see the outer line, a very compressed one here, and then the bottom one here being brought in position. The general arguments for going for a selection of a stick system or unitized system, stick systems are in general a lot less costly than a unitized system. This mainly depends on the number of manufacturers being available to do so. Unitized systems obviously being made, being fabricated in the factory, do tend to have a better quality depending on who's installing. Scaffolding is an interesting aspect. For a stick system, we need to have a scaffolding to get it installed, especially from outside, versus unitized system, which can be installed by the crane, so no scaffolding is used, which means that mainly for high-rise buildings, this is something which is interesting. And obviously, we have to take care with the unitized system when we transport them to the construction site, that they're not damaged, which can be an issue with stick systems. You obviously can maybe exchange components on site, maybe an easier setup. And obviously no scaffolding with unitized systems. So unitized systems tend to be faster installed because lots of work is done at the factory as a system. By this, I end with the final picture of the authors of this lecture and where this whole thing comes from, and end the lecture here.